Right. So I'm going to start recording, and let's go over here. All right. Yeah, so we're talking about level design, and so obviously we want to start with what is a level. And so, as gamers, I assume you guys have a familiarity with this term. It probably seems pretty basic, but there's a sort of conceptual component to what a level is, as well as a technological component to what a level is. So we'll kind of talk about those two things just to get started, so we know what we're talking about before we start to talk about level design. So in video games, a level is typically defined spatially. A level and the design of that level includes all the space that the player can navigate at the current stage of a game. And this is true, this isn't 100% true, but this is true across a lot of different types of games, whether they're RPG style games or adventure games, action games, FPS games, all these different types of games. Usually a level is defined by the space of the game. So where we can move our character, where we can move the objects in the level, the boundaries of the level, how we navigate the level. All of these are kind of like elements of the spatial elements of the game. In some games, the entire space is visible to the player at the beginning of the level. In many games, the player needs to navigate through the space to reveal the boundaries or the extent of the level. So here's an example of a level in Pac-Man. And all of the levels in Pac-Man are basically the same, with some of the rules changing. So the space kind of defines the level, but the levels can also use the same space but introduce new elements. So that's an important aspect as well. And so yeah, in this level, we can see the entire design of the level. Like, we have this top-down view of everything that's in the level, how everything fits together, and we are, manipulating our character to move through the level. So in a lot of games, we can't see the whole level to begin with. We have to kind of figure out, how far can I go? Which direction am I supposed to be going in? Where can I find, the obstacles or the rewards or different things, the goals that I'm looking for? So that's kind of one way that we think of about a level, and the design of a level is the space, and the space that we're navigating inside of a game world. Most games consist of a sequence of levels. Typically the difficulty gets harder as we go through those levels. Levels can represent a section of a larger space or a larger world. So you might have a map with levels that are in different places. And to get through a level, usually we have to navigate a space, but we also have to, solve puzzles, defeat different challenges, defeat enemies, find certain rewards, things like that, to advance from one level to the next. So there's usually some challenge that sort of marks the end of a level, and the beginning of a new level. So from a technical perspective, levels are collections of data that have a series of references to the components that make up a game. And the reason that games work that way is because obviously we're using the computer, and we have limited resources, and so we want to reuse things. Like, if we have a player, we want to have a player inside our level, but we also want to have the same player in every level. So that's kind of how we're designing our game in Godot, where we have like our main scenes, and then we have our player scene, and then we have these different components. And by breaking them up into the different components, we can sort of save time building levels, and we can save space on the computer. So a level is not necessarily the images and the map and all those things, but it's actually just references to where to find those things. So even when we're making like the tile set or the map of a level, that's just like a design that could be used anywhere. A level is just a collection that's kind of pointing to, this is what player I want to use, this is what obstacle I want to use, this is what map I want to use, and it brings them all into one place. So technically, the data in a level is not as big as like the art and the other components of the game, but it kind of points to everything and says this is where it should fit together. So it's kind of like a little recipe for the game, and that goes into the game engine, and it builds the level for the player to see. So the level has to have references to all the different components of the game: the programming, the scripts, the images, fonts, the tile maps, all of these different things that we're creating. The level has little pointers to those things. And usually we create those levels through the Godot scene, panel. So when I'm in Godot and we have that scene hierarchy on the top left corner, that's really the data of the level. That's where we're saying this is what goes into this scene. This is what it actually looks like if you were to open up one of those Godot scene files that we've created. This is what you would see. So if you read through this, it's just a bunch of text. You could theoretically like write a whole level just by writing text like this. It would be pretty hard to do, but it would be possible. And you can see there's some conventions. It looks a little bit like code, but it's not the same as the Godot script that we write. But you can kind of get a sense of what's going on in here, right? Like it says GD scene, so it's a Godot scene. Load steps 24, format equals 2. I don't actually know what that means. Load steps equals 24. That might be like how many things it has to load. I'm not really sure. But then we see these external resources. So that's what that means, external resource path. And then there's a link to this player. And it's a packed scene, ID is 1. So there's our player. So it's basically saying grab the player. The next thing it's doing is saying grab this camera. We actually don't have this script in our game. This is from an old version of the game. But you could imagine that that would be a script that we'd have. Then grab this platforms image, grab this clouds image, grab this item scene. It's all these links are to external resources that we want in this level. After that, we have positions for where these things should go. And so all of this stuff in Godot is basically just saving what we edit in the editor file. And that's what most level files look like for any type of game. Here's more data. So we can see our tile data. This is where all the tiles are going. So it's all just this like information, numbers and references and stuff like that, that helps Godot rebuild the level after we design it for somebody who wants to play it. So that's sort of the technical aspect of a level design. But doing that is really tedious. So we usually have level editors. This is a good example of a level editor from this link of all these different level editors. So you can see these different levels, and then a lot of games have level editors, and a lot of like software companies have to create software to build their levels, and then a lot of the time they'll make those software open source so other people can build levels in the same game environment. And so you can see this is an old level editor. It looks a lot like Godot. Like we have our little map here with different nodes in the level. We have our tile sheet down here, and then there's the level design here. So yeah, as I mentioned, in early game development, as well as today, a lot of studios are going to create designer software to design levels. It might be something that never leaves the studio, like only the people in that game studio will ever use it, but they'll create that software to make it easier for the designers. Instead of having to write everything in code from scratch, you can use a visual editor to set up your level. So this is an example of a level editor from ZZT. We talked a little bit about this a few lectures ago. This game that was one of the first games to make their level editor open source. So any player of the game, any user could make their own levels and then distribute those levels on the internet for other people to play. And so this is a pretty bare bones level editor, but you can see it looks a lot, it has a lot of similarities to how Godot looks. Like we have the view of the level, we have the information in this bottom right corner that's sort of like the inspector. And then you have the files over here. So you have different scenes, and you can see this particular scene is called the Thief's Fortress, and this is what the level looks like. And those are kind of some of the options and stuff like that. This is from a really interesting article about the graphics in ZZT, which is just using these like ASCII characters. So it has these very sort of retro looking graphics. So that's a cool article to check out if you're interested. So yeah, some games like ZZT share their level editing tools with players. So there's a community around user generated levels. Other games like Doom and Half-Life have shared the source code or the engines for making levels. And this leads to creating game mods. So games that look like the game or have similarities in terms of like the physics or the rendering to the game, but are, their own separate games. Probably one of the most famous examples of this is the Stanley Parable. I'm sure a lot of you guys have played that game. It's a really interesting sort of like meta narrative game about playing video games. I highly recommend it if you haven't played it before. And there's some news recently. Oh yeah, it says right here there's a new one coming out pretty soon, so that's kind of cool. So yeah, I'm excited for that. But this is using the Half-Life 2 engine, which at the time was this very like, cutting edge, sophisticated engine. And it was made open source for people to use and create their own levels. And the Stanley Parable was made in that engine, and then it became its own game, and it was very successful in its own sort of lifetime. So yeah, another style of level generation is procedural generation. We talked a little bit about this when we were talking about Rogue and other roguelike games. And this is a different style of creating levels where instead of actually designing and dragging things around and saying this is where this platform goes and this is where an obstacle goes, you write code that makes choices about where to put things based on some randomized inputs. So that requires a lot more coding. Most of the time, it's a little bit trickier to do. I actually really like it as a style of level design. I use it in my own work a lot. And it's something that if you guys are interested, we could talk about more. But it requires a little bit of a more coding work than traditional level design. Okay, so let's talk about some level design principles. So again, this isn't exhaustive, but this is just a few different ideas that can help you think about how to start a level and what to add into a level, and not just kind of throw random stuff in there. And a lot of level design can be intuitive. If you've played a lot of games, you might have a sort of like basic sense of how a level is supposed to go, and so you can recreate that when you design your own levels. But if you learn the principles, you'll start to notice them in a lot of different games. And so this is sourced from a few different places. I have some links at the bottom of this these notes for stuff where I got a lot of these different ideas from that I recommend checking out. So yeah, let's talk about some level design principles. So these aren't like hard rules. They're not things that you have to do or your level is like, wrong or something like that. But they're some basic guidelines that can help a designer, really even, not necessarily new designers, but any type of designer, think through how to create a level. And it's a process. There's a discovery through practice that happens. So the first level that you make in your life is not going to be probably the best level ever. It might be, there's no reason it couldn't be, especially if you've played a lot of games and have, a sense of what you want to do. But most likely, like drawing or painting or, any other type of art, you're going to get better at level design through practicing, through making lots of different levels, through playing those levels, getting other people to play the levels and tell you, what they think. We can learn these principles, but we also have to do the practice. We actually have to build levels to see how they work. So the first principle, and this is usually the first principle because it's usually the first thing that happens in a level, is guidance. And guidance is basically the idea that you show a player what they're supposed to be doing. So most players may have some idea like, oh, if I click on something or if I hit space, it's going to jump or something like that. But not everybody knows that. So you kind of have to give people some guidance as to, when you start a game, this is what you're looking for. This is what you want to do. And so guidance is the idea of introducing the mechanics of the game. Usually this is like an explicit tutorial. You might have, in a lot of games, it'll start with like, okay, you're in this world. Now hit the, space bar to jump and hit the arrow keys to move around. And you'll actually have an explicit tutorial of teaching the player how to go through things. So that's part of guidance, but it's also guiding the player through the beginning of the level. A lot of levels will use like signs that say, go over here, or, more implicit signs like a light that's blinking or something like that to show the player what they're supposed to be doing at any given point in the game. Here's like a breakdown of Mario World 1. And obviously, the design of this game and this level has gone through tons and tons of analysis and discussion. And one of the really basic things that you see here is that, your character that you're controlling is moving to the right. and the bad guys are moving to the left. So you immediately get this sense of the mechanics of how the game works, that you're trying to go this way and things are coming at you from the other direction to try to prevent you from getting there. And so, in this diagram, we're kind of taking out the art and just thinking about the basic movement and the basic elements of the game. And so we kind of see this, the essential quality of the mechanics. And this is also a form of guidance. It shows us like, okay, this thing is coming from over there. Maybe that means I need to go in that direction. Guidance also, it's important to introduce the goal of the game, especially really early on. A lot of people, if your game doesn't have like a good or obvious goal, people are going to get bored and complain, there's no reason to play this game, or I don't know what I'm supposed to be doing. So even if the goal is something that's abstract, like exploration, it should still be clear. It should be clear if your game is just like exploring, like a pretty forest or something like that. It should be very clear from the beginning of the game that that's why you're playing the game. So, there can be some mystery as to what, maybe your game has like a big twist in the narrative or something like that. You don't have to tell the player everything that happens in the game, but you have to give them a sense of what they're there for, what they're going to be doing. And that'll give them a motivation to explore or, test out the controls or see what they can do in the game. Okay, obstacles and rewards. We've talked about this a ton. Once we kind of teach the player how to play the game and how the game world works, how the physics work, things like that, where they're supposed to be going, that's when we start to introduce different mechanics like obstacles and rewards. So obstacles obviously are challenges that should be fun and should engage the player. So they should be kind of hard, but not too hard, and increasing in difficulty, all the stuff that we've kind of talked about when talking about obstacles. And then rewards reinforce the goals of the game. So they lead the player towards, understanding the mechanics better, getting better at playing the game, getting things that help them play the game better. Like if you get some reward that makes you jump higher or something like that. So obstacles and rewards are part of the principles that we want to introduce into a game. Sonic is a really good example of this. There's just like a ton of rings. You get a nice kind of sound when you collect a ring. It's very exciting. And that just like leads you through the game. So you always know what you're supposed to be doing because you're always collecting these rings. It's this constant feedback that's happening. Another principle that's a little bit more abstract is the perfect player principle. I really like this idea because I think it's something that's good to keep in mind as you're designing a game. This is basically the idea that in theory, this isn't necessarily going to happen, but in theory, there should be some player who's so good at playing video games that they can play your level without making any mistakes. Or no, not necessarily not making any mistakes, but like get through the level in one run. And I think, as gamers, we're used to like, we play a game, we try some different stuff, we die, and we start over. And that's a normal part of the game process that teaches us how to play the game. And I think this isn't necessarily saying that your game should be easy enough to beat the first level or any level in one try, but it's saying that your game should have enough balance of guidance and challenge that if a player is really good and they're really paying attention and getting all the signals that you're giving them, they should be able to get through the level in one perfect playthrough. So that's basically saying like, you shouldn't have a game where you have to die in order to win the game. Like if you're just really good at it and you understand like, okay, I can jump exactly this far, I can run exactly this fast, I understand what's being sort of communicated about the world of this game, then I should be able to get through the game without having to necessarily, die a bunch of times or having other frustrating things happen to me. So again, this is not every player. This is this ideal player that doesn't really exist. But I think it's a good thing to keep in mind because you don't want to build into your game things that are frustrating. You don't want to build into your game like, oh, nobody's going to be able to do this and it's going to be really annoying. Unless you're trying to make some sort of commentary about, game difficulty or something like that, and it's intentional. But this is something that you want to keep in mind. People should be able to actually progress through your game, even if it's the first time that they've played it. This is kind of a random example, but I use the game N as an example for this. I don't know, maybe you guys have played N, but it's a very complex physics platformer game. and it's really, really hard to play. But it does work, it follows the perfect player principle. If you're really good and you understand the physics, you can beat this game without, losing a bunch of times. All right, another principle to keep in mind is unique levels. This is pretty straightforward, but just the idea that each level should be unique. You shouldn't have levels just for the sake of having more and more levels, just for the sake of having a long game. If you're going to have multiple levels, there should be something different about the levels. It doesn't necessarily have to look different, but it should feel different. And the way that you know that this is happening is if your level has, if a player can play your game and then describe a specific level and you know exactly what level they're talking about. So if you have a game that's 10 levels and they're all basically the same, but there's 5 more enemies in each level, your player's going to finish the game and they're going to have no idea, they're not going to remember the progress of the game at all. But if you have a bunch of unique levels with different themes or different characters or different ideas or design principles, the player's going to be like, that level where there was, this happening. They're going to remember all of these different levels. So that's a good thing to kind of aspire towards when you're creating a game. The purpose of making levels is to make new challenges, new rewards, new goals, make things that are more interesting for the player. It's not just to make the game longer. A really good example of this principle is this specific level, but also the whole game, Psychonauts. I don't know, I feel like maybe we talked about this game before in this class, but this is a really good game. It's kind of an old one, but it's had some sort of like, cult following and resurgence in recent years. And it has just each one of the levels is really, really unique. And one level in particular that people really like is called the Milkman Conspiracy. And you're playing in all of the levels in Psychonauts, you're playing like in the psyche of these different characters. And they all have these kind of like different, things going on. So it's a really cool, this whole game is really great, but this level in particular is really famous. And, anybody who's played that game, if you say like, oh yeah, the Milkman Conspiracy level, they'll immediately have an image in their head and an experience of playing this level. They know exactly what you're talking about. Okay. Another principle is the idea of pacing. Okay, so it's pretty, this is kind of what it sounds like. The idea that a level has to offer a series of challenges without ending too quickly or getting too repetitive. So if your level is really short, it's probably, not that interesting. Unless it's like a really amazing, there's a lot of stuff packed in there. There isn't like a specific time limit for these things, but in general, there should be kind of a series of challenges that you get more used to what's happening in the game world. You start to get better at the controls. You kind of get introduced into the game. But you don't want to have it so long that you're just kind of like, okay, I'm still jumping over these platforms over and over and over again. This is a good level, but a level that, you guys might think of when it comes to pacing is the Water Temple from Ocarina of Time. I'm sure a lot of you guys have played this game. This particular level is just notable for how much you kind of have to like go back and forth to complete the challenges. You have to kind of like retrace your steps and go through this big maze over and over again to actually complete the level. It is, it's kind of a really unique level. Like I'm sure, a lot of people have specific sort of memories or experiences of this level. So it's successful in that sense. But a lot of people also really hate this level because it is, the pacing is so repetitive. You have to kind of do the same stuff a lot of the time. Okay, so those are some basic principles. Again, not exhaustive, but just some kind of like things to be thinking about as we're talking about creating levels. Level design techniques. So this is a slightly different sort of category of things. These are like ways of actually, things that we actually design into the level. So again, not an exhaustive list, but a few things that will help you achieve some of these principles. So signposting, this goes along with guidance. This is just like the literal implementation of signs, whether they're, texts that tell you to do stuff, or arrows pointing you in a particular direction, or more abstract, like a blinking light, or, a sound that you're drawn towards. anything that draws the player's attention towards one place or another in a level is referred to as signposting. So, most basic example, you walk up to a sign and it just tells you to do something. But this also applies to anything that sort of says like, oh, look, there's some stuff over there. I wonder what that is. I'm going to go over there. Good level design, if your eye is drawn towards something or your attention is drawn towards something, it's usually because the designer intended for that to happen. Another technique is gating. This is very common, like pretty much all games use some form of this. Gating is just restricting parts of the level. So it involves two parts. Part of it is showing the player the gate. So it's something that says you can't come in here, whether it's like a door with a lock on it or an actual physical gate or whatever it is, some type of gate that prevents you from getting to an area. And just having that gate there is going to be a motivation for the player to say, what's behind that gate? I want to figure out how to get past there. And so that's part of it. The other part of it is how do I get past? So I need to find a key or solve a puzzle or, get a secret password, whatever it is. That's how we have to have some way of getting through the gate. And that usually leads us to explore other parts of the level. So it's a really useful technique for saying like, this is where you want to go, but you have to go find some other stuff first. The ice key is just kind of an example of like a really hard to find key in Banjo-Kazooie. If you guys have ever played that game, it's a fun one. Risk versus reward is another technique where you present the player with two possibilities. One that's a high risk and high reward, or one that's lower risk, lower reward. And so you might have, two paths, one that goes through a dangerous area, but leads you to a more advantageous spot on the map, or, somewhere where you can hide and wait for the enemy to pass. That's the basic idea of risk versus reward. High risk should be accompanied with high reward. Low risk is accompanied with low reward. Example of this is the Blood Gulch level. I mean, pretty much every good level in any game probably has examples of all of these things. So I'm just kind of picking some random ones, but I think a good example of this is the Blood Gulch level, which is a really famous Halo level. People talk about it a lot as just a really good sort of like combat design where there's these high risk scenarios where you have to kind of like run out into this valley and you're very exposed, but you have you have more chance for attacking the enemy versus like hiding and trying to play more safe. So Blood Gulch is an example of a level that kind of forces you to take high risk options in order to play the level. A safe zone, this is a little bit related, but a safe zone is an area where the player is safe. And so they can evaluate what's happening in a level and then just make decisions about how to navigate. A really simple example of this is Space Invaders. You have these areas where you're safe, you can't get killed by the aliens. And so you can hide behind those areas and then figure out what's the timing of the aliens. And so then I can jump out, shoot the aliens, and then go back to a safe zone. So this is a good principle or technique to use as you're introducing new obstacles. So you might want to give the player a safe area to observe how an enemy is walking around. And then you can guess, okay, so if I go at this time, I can sneak past the enemy, or I can sneak, I can secretly attack them or something like that. So safe areas are good to build in as the player is getting used to a level. You can see with Space Invaders, part of the challenge is that eventually those safe areas get destroyed. So you have these safe areas, but you also know they're not going to be there forever. So that adds to the challenge of the level. Another technique, foreshadowing. Foreshadowing is revealing future rewards or challenges to the player before they reach them. This can be a lot of different things like the goal, the rewards, different things that give motivation to the player. This is an obscure example probably, but it's from a game that I really, really like called Outer Wilds. If you guys haven't played that game, it's a relatively new game. I think it's like one of the best games that's come out in a long time. Like it's really cool, non-linear narrative storytelling, really awesome space mechanics. Like it's a really great complex game. And this is just an example. This is the first thing you see in the game. And obviously I'm not going to ruin anything, but if you don't know what you're looking at, it's just like, oh, it's a cool space scene. And as you play the game, you start to figure out, actually, there's a lot of stuff happening in this very first image that kind of reveal things about what I'm looking for in the game. Branching is also giving the player multiple options for how to complete a challenge, how to avoid an obstacle, how to collect a reward or reach a goal, any of these things. So branching is just saying, here's some different options. You can go up and fight the bad guys, or you can go down and, hide, or, giving the player different ways of completing a level. This makes the level more interesting because you can come up with different strategies and see how they work. Bottlenecking is the opposite of branching. So if you have some branches and then they come back together at a certain point, that's the bottleneck. And so that's typically how a lot of games work. This is kind of a good example of this is for narrative style games, but games work like this in general. You have these different styles of games where this is an example of branch and bottleneck. So, you start the game and then you're presented with a bunch of options. You choose one of those options, and then all of the options lead to another, section. And so maybe they change something about what happens in that section, but the bottleneck is when we all go back to this section. So this is a cool article with some different ideas about structuring levels and games in general. Layering is the technique of putting multiple components together. So you might start with, here's a bad guy that's going to kill you, and here's a thing that you can use to get away from the bad guy, and then here's both of them together. Mega Man has a lot of this stuff where it'll show you, okay, this is how one bad guy works, and then here's how another bad guy works. Now, how are you going to deal with it when both bad guys are in the same place? Because they have different physics. So, you figure out how to beat the first one, you figure out how to beat the second one, but now dealing with both of them at the same time, that's an extra level of challenge. So that's referred to as layering. Okay. So here's some resources. So those are some basic techniques. I'm going to go over actually using these techniques in my example on Thursday. So I want to introduce those terms so we're all familiar with them, but then I'll actually show how to build them into our game. So we'll look at practical examples of all of those. Some of the articles that are linked here, this level design lessons is like a free resource. I think it's just a PDF that goes over a lot of different types of levels and it has a lot of really good examples. This is a good one to check out. This is a GDC talk by Robert Yang, who's a game developer. I think he works at NYU. And he's made some really interesting games, kind of like indie games and stuff. And this talk he gives is, to me, it's one of the best talks about level design because he just brings so much different stuff into it. Like he's talking about politics, he's talking about architecture, all these different things that are happening when we're thinking about a game level. So this is like an hour-long talk. It's not required, but it's really, really good. I recommend checking it out. This is some examples of level design.
I'm making a video game.
For this very specific game. I actually have never played this game, but I just think he does a good job of talking about the process that he went through in designing this game, and he gives a lot of different examples. It's sort of this video-based devlog. This is a good one talking about different level designs. He talks a lot about making unique levels and how he designs his levels. This is another level design philosophy video. Let's unmute that. So again, just talking about different level design ideas. This is a game that this developer is working on, and you can see each one of he talks about the different levels and the different themes that inform these levels, and how he comes up with them. That's a good one. This article talks a lot about the specific techniques that I was talking about, and I think it adds a few more as well, and it kind of gives some different examples. of these different techniques in different contexts. So this is a good one to kind of reinforce a lot of these ideas. Also has a lot of references for other stuff. Leveldesign.org is just like a whole website with resources about level design. So there's lots of articles, there's a database, there's interviews, all sorts of different stuff. So this is, if you're interested in level design, this is a good resource to just like go deep and see lots of different options. And there's a few other ones like this, World of Level Design, kind of similar thing. Some different articles and courses and stuff like that. A lot of resources here. And then a procedural level generation article, if that's something you're interested in. This goes into a little bit more about how procedural generation works. So that's a good one if you're interested in that. All right, so that's level design. As I mentioned, I'm going to go over this in practical terms on Thursday when we start building a level. Let me stop recording.